Assalamu alaikum guys. I hope this is the first short video on YouTube about bar bending schedule of one-way slab. So therefore watch this video till the end to learn something new about bar bending schedule of one-way slab. More people did this topic on YouTube, but this is a short about bar bending schedule of one-way slab. Let's get started. If this video is helpful for you, so you may like this video. Guys, you can see this is one-way slab and we will make bar bending schedule for this slab, that how much steel is required to cover this one-way slab. Guys, first of all, I will tell you about its data. The length of this slab is 6000 millimeter or 6 meter. The width of this slab is without width of the beam. Without width of the beam is 2.5 meter or 2500 millimeter. Now guys, you can see these are crank bar here, okay, main bars, but these are crank bars also. And you can see these lines, the black lines can show you distribution bars and the red line can show you the main bars. So the distribution bars dia is 10 millimeter with a spacing of 150 millimeter, right? And the red lines which can show you main bars, which dia is 12 millimeter with the spacing of 150 millimeter. Okay, so also guys, you can see its section. Okay, you can see the crank bar also, or bent up bar you can say. So let's discuss its given data. First of all, guys, you can see size of the slab is 6000 millimeter by 2500 millimeter and the thickness of the slab is 150 millimeter. So therefore 6000 millimeter by 2500 millimeter by 150 millimeter. So main bar dia is 12 millimeter with the spacing of 150 millimeter. Distribution bar dia is 10 millimeter with the spacing of 150 millimeter. Slab thickness is 150 millimeter. Extra bar are 12 millimeter and concrete cover is 12 millimeter with the spacing of 150 mm. And concrete cover is 25 millimeter. Okay. So the first step is we will find the total, finding out total number of main bars and distribution bars, that how many numbers are required for main and also for distribution. Okay, so the first step is we will follow three steps, okay, by which we can calculate or we can make bar bending schedule for one-way slab. Okay, so finding out the total number of main bars and distribution bars. So first of all, I will find number of main bars. So to find the number of main bars, the formula is length of longer span. So length of longer span, which is 6000 millimeter. So plus divide by C/C. So center to center distance between two main bars. Okay, plus 1. So where the length of longer span is 6000 divided by 150, which is center to center distance spacing of main bars, plus 1. So we required 41 numbers of main bars. Second, number of distribution bars. Length of shorter span, which you can see guys, which is 2500 divided by center to center distance, means 2 distribution bars are spacing, you can say plus 1. So the shorter span is here, the length of shorter span is 2500 millimeter and the spacing is 150 mm plus 1. So we required 18 numbers of distribution bars. Okay, now the second step is find out cutting length of main bars and distribution bars. Okay, so now we will find the cutting length of distribution bars. The first one, main bar, sorry. Okay, so the main bar cutting length formula is clear span plus 2 beam width. Okay, 2 beam width. Okay, the width of the beam is 240 millimeter each side, 240 and 240. Okay, so therefore clear span plus 2 beam width minus 2 concrete cover, one side concrete cover, other side concrete cover, which is 25 millimeter. Okay, plus 1 inclined length, which is for bend. Okay, so this length, this one or this one, plus 1 inclined length. Okay, so therefore you can see and minus 45 multiplied 2, 45 2. That's why, because we will deduct its band. Okay, so as I told, if you don't know about this, so the link is in the description of this video about formulas for bar bending schedule. Okay, bar bending schedule formulas, basics formulas. So you will find there what is this. Okay, so therefore inclined length is equal d inclined length is equal 0.42d. so I have already discussed, the link is in the description of this video as I told you before. So where d is thickness of the slab, which is 150 mm. Okay, so therefore where thickness of the slab minus 2 concrete cover minus bar dia, then we will get the inclined length. Okay, so therefore you can see guys, so here 150 is the thickness of the slab minus 2 concrete cover, so 25 plus 25, 50 minus 12, where 12 is dia of steel rod. Which one dia of steel rod? This one, main bar. Okay, so this is the formula. Therefore the inclined length is 88 millimeter. Okay, so therefore let me use the 88 in this formula. So the formula is 0.42d. so we are 0.42d multiply 88, this one. So the length, the inclined length is 37 millimeter. Okay, so in the formula we put it already. So now guys, cutting length of main bar. What is the cutting length of main bar? So the cutting length of main bar is, as you can see, cutting length of main bar, yes, this one, cutting length of main bar. So the cutting length of main bar is here, you can see 2500, as you can see, clear span 2500 mm plus 2 multiply 240, where you can see 2 beam width. Okay, be careful in this place. Okay, so 240 plus 240, so therefore 2 multiply 240 minus 2 multiply 25, so 2 concrete cover plus 37, whereas 1 inclined length. Guys, you can see one side we have inclined length of bent up bar or crank bar, you can say, and subtract 24, where we can use the formula 2d, where d is 12, so 2d for the 45 bent, we have 2d formula to deduct its bent. Okay, so 2d, the 2 is constant and d is die of steel rod, which is 12, so 2 multiply d, we will subtract or minus 24. So therefore the cutting length of main bar should be 2.95 meter. Okay, so now find out the cutting length of distribution bar. So the distribution bar cutting length is, the formula is clear span minus 2 concrete cover. So the clear span is 6000 millimeter, where I put it 6000 millimeter minus 2 concrete cover. So one side concrete cover is 25, other side concrete cover is 25 millimeter, so minus 50. So the cutting length of distribution bar is 5.95 meter. Okay, now guys, the step number 3 is find out number of top extra bars. So also we provide top extra bars. Okay, you can see in the picture, these are top extra bars, so which is L by 4 distance, as I told you in many videos that the end of the at the end of the support we will provide the extra bars, okay, to resist shear stresses. So therefore to find out the numbers of extra bars, okay, so crank length divided by 4, so we can get the crank length, so L by 4, as I told you in many videos, divided by spacing plus 1, so dia is 12 millimeter for extra bar, the spacing is 150, so therefore 2500, which is this one, extra bars for extra bars. Okay, we will find the extra bars. Now divide by 4, because with L by 4 distance we will provide extra bar. Okay, so 2500 divided by 4, again divide by 150 spacing of extra bar, which is 150 mm plus 1, so we required 10 numbers. So therefore now what is the length of top extra bar is equal same cutting length of distribution bar. So when you do its calculation, so you will get the same length which is for distribution bar. Okay, so guys, these are the find out the numbers of main bars, distribution bars. The second, find out the cutting length of main bars, distribution bars. The third one is find out the top extra bar cutting length, okay, in numbers. Now guys, you can see this is the bar bending schedule you can say the table by which you will put the values. Okay, so the first column we have description, the second dia of bar in millimeter, third number of bar, fourth cutting length in meter, 5 weight of steel bar per meter, the last one quantity in kg. So therefore main bar in description. So the main bar the dia of bar is 12 millimeter, as you can see here, 12 millimeter. Number of main bars are 41 numbers, so I put it here 41. Cutting length is in meter 2.95, so here you can see this is the cutting length. So weight per kg is 0.8888 kg per meter, because when you use the formula d square divided by 162, and if you solve this, so 12 multiply 12 divided by 162, so you will get the value 0.88 kg for 1 meter. Okay, so therefore the total weight of main bars are 106.43 kgs. Okay, because 41 multiply 2.95 multiply 0.88, you will get the value 106.43 kg steel required for main bars. Now distribution bars, the dia is 10 millimeter, numbers we required 18, cutting length is 5.95 for distribution bars, and the unit weight of steel is 0.62 kg per meter if you put the value in this formula, which is 10 multiplied 10 divided by 162. So the total steel are required for distribution bars 66.40 kg, quantity in kg. Therefore top extra bars dia is 12 millimeter, as I told you before here. Numbers we have 10, the length is same like distribution 5.95, weight is per meter 0.88, so the total weight is 52.36 kg. So the total weight of steel is required to cover this one-way slab with extra bars, distribution bars, crank bar, anything as I discussed before. So we required 225.19 kg. So you can say 226 kg steel is required to cover this RCC slab, one-way slab. So hope this video can help you. Guys, this is a short video on YouTube, first time about bar bending schedule. So many people, they did this topic, but the video is very long, but this is the first short video. Hope this video can help you. Thanks for watching. See you in next video.